Hello friends, welcome back to Digitalk. So this session is again absolutely for the beginners. Okay, and I'm going to talk about multiple things in this session. Okay, for example, we have a different kind of distributions of Kubernetes. Okay, you may heard about that. There are a lot of Kubernetes available on the from the multiple cloud service providers. Like, and apart from that, we can do a local setup as well for the Kubernetes, either in on-premise machines or you can do it on the local machines or laptop as well for your testing purpose. Okay, testing and demo purpose for your learnings. Okay, so you have a different kind of a distributions on cloud, on premise. You can have on your own local system as well. Okay, then there are a lot of questions. Okay, how we can start when we are talking about the Kubernetes and we have to do the setup of that one. What are the basic things from scratch or from starting we have to follow? Okay, when we go for the setup of the Kubernetes for the self-learning. Okay, so let us begin with that. So in few of the previous sessions, okay, that we have made for the beginners, okay, what we have learned in Kubernetes, you have two major components. One is a master node and second is the worker node, right? And what we have in the worker nodes, we have the different pods. Okay, each and every worker node, we have a multiple pods are running. So in figure, you can see there are two pod in each and every worker node. So it could be many. Okay, there is no limitation. It depends on the kind of resources that you have in your worker node. Okay, this worker node is nothing but it is a physical or server or it could be a virtual machine. Okay, which is defined as a worker node because we have a pods are running there. Okay, and all these pods contain the containers. So our applications, okay, are run inside the containers, okay, and the grouping of containers are categorized as a pod in the Kubernetes, right? So what this master node is doing, this is the master node which is doing the end-to-end administration of your all the worker nodes. That means you have a multiple pods running across the multiple worker nodes. Inside each and every pod, you have a multiple containers are running, right? So you need something which can control or operate or manage all of this worker node at the same time. For example, if I am suppose that I am doing a deployment of one of the application, okay, or in terms of Kubernetes, we can say the deployment of a pod, okay, which is across the four nodes. So I have to do the deployment of same pod, or you can say for the same application across all of the worker nodes, right? So it is not feasible for you have to go to each and every worker node and then do the same kind of stuff again and again on each and every worker node for the deployment of your applications or deployment of your pods. So for that you need a centralized system, or you can say centralized controller which will manage all of these things for you, right? And apart from that, there are a lot of benefits. You have to do a scaling of your environment, and then you have to restart your pod. You have to delete and restart or recreate your pods in multiple worker nodes altogether. So there are a lot of benefits that you can achieve with the help of master node. That's why the architecture of Kubernetes is you have a one master node and multiple worker node. This master node is the centralized central point of contact, which does all end-to-end management of your worker node, right? So that means you have a separate master node. Okay, if I go to the real-time production environment, you will have a separate server for the master node, and then you have a multiple worker nodes. It could be physical servers or it could be the multiple virtual machines, but they are different machines, right? So that means you need some mechanism. Okay, when we say about your master node is controlling your worker nodes, okay, you need certain kind of a software or certain kind of a component which allow this kind of a mechanism where your master node, which is running on some different server, is controlling your different worker nodes. And apart from that, it is allowing you multiple more features, like you can do the auto scaling of your environment, you can delete your pods, you can recreate your pods. So these kind of features are provided by your master node. Right. So that means there is certain communication mechanism is required between your master node and your worker nodes. And along with that, between the worker nodes as well. Right. So for that one, we have a Kubernetes where there is a lot of component that where we deploy on the master node as well as on the worker node. And there is a specific task of each and every component that we have in the Kubernetes. Right. So now let us talk about from the scratch again when we say about that, okay, we are going for the setup of the Kubernetes, okay. So for Kubernetes, the basic thing is you need a containerized solution, okay. And as I said in the previous sessions as well, so Docker is one of the leading containerized solution, right, that is mostly used as of today in the professional environments. There is no hard and fast dependency to use the Docker. There are multiple other containerized solutions are available in the market. For example, Containerd and many more. Along with that, you can use the virtual layers as well instead of the Docker. Okay, so there are multiple options that we will discuss in some other sessions. Okay, so in a nutshell, you can say you need a containerized solution, and what we are saying that for a containerized solution, we are going to use the Docker engine. Okay, so that means when we have a Docker engine installed, then we can create the multiple containers, right? Because this Docker engine allow you to create the containers. Okay, so this is the basic requirement of your Kubernetes. You should have a containerized solution in place. That means Docker in our case, right? And once you have the Docker engine, or you can say the containerized engine, and then you have multiple containers are running inside the Docker, then you need a Kubernetes. Okay, and what does this Kubernetes does is it do the management of your multiple containers, right? And what we have seen in the previous screen slide, that these containers are running inside the different pods, right? This is the which is the feature of your Kubernetes. Now, so if you are going to set up your Kubernetes, okay, whether it is in a professional environment, in your local machines or anywhere, you need to install the containerized solution. Okay, so that means in our case, we are using the Docker engine. So the first step, you have to install the Docker. Okay, so even if you are doing a local setup of your on your local PC that we are going to cover in the next few sessions. So first thing you have to install the Docker. Okay, because we are going to use the Docker as a containerized solution, right? So once your Docker is installed, the second step is to install the Kubernetes, right? Because it is going to use the underlying Docker engine as a containerized solution, right? So these are the first two major steps when you are going for the setup of your Kubernetes. The first, install the containerized solution. Second, on top of that, you have to install the Kubernetes. Right. So now when we talk about the different kind of distributions of Kubernetes, this is a very important features you can say about, okay, of the Kubernetes, that it comes in a different variety of distributions. Okay, the first one is the managed Kubernetes, and this managed Kubernetes is specifically relate with the cloud service providers. Okay, that means whatever the Kubernetes solutions that provided by the multiple cloud service providers, it is termed as a managed Kubernetes because it is managed by the third party cloud service providers. Okay, for example, you have a Google Kubernetes engine which is called GKE. You have Amazon Elastic Kubernetes service which is EKS. From Azure, you have a Azure Kubernetes service AKS. From IBM, you have IBM Kubernetes service. Similarly, from Oracle, you have a Oracle Container Engine for Kubernetes Oak. Okay, so these are the solution, or you can say these are the Kubernetes solution that has been provided by the multiple cloud service providers. So when we use the cloud service providers for this Kubernetes, okay, then the task to set up the Kubernetes is very easy. Okay, you only have to select few of the parameters. For example, the master node, what is the configuration of the master node, then how many worker nodes you need in your cluster. You have to specify the count, and then you can give the specifications of your worker node. What is the RAM, CPU, and kind of a things. So you have to provide certain basic inputs to that, and then the cloud service will automatically create the Kubernetes cluster for you. You don't need to do anything manually apart from that, giving certain kind of inputs that is required to build your infrastructure. Okay, so that is very easy in that case when you are using the managed Kubernetes services. Second is your self-managed Kubernetes services. So self-managed, that means you are doing the complete end-to-end setup of your Kubernetes in your own machines and in your own environment. Okay, for example, like in a traditional data center where everything is managed by the organization. Okay, so now in that case, the things will get complicated, right? Because you have to do everything by your own. Okay, so for example, if I'm saying that you are going to configure the self-managed Kubernetes in your own data center, then you have to provision your different machines for that one. Okay, once your provisioning of machines is completed, then you have to go for the installation of each and every component of your Kubernetes. Now, as you can see on the screen, these are the core component of your Kubernetes that we will cover in next few sessions. Okay, so as of now, what you can understand, as we said in the previous slide, that you have a certain component installed in the Kubernetes master node and some of the component installed on your worker node, right? So these are a list of important components: kubeadm, kubectl, scheduler, kubeproxy, control manager, kubelet, etcd, and API server. Okay, these are the multiple components that need to be installed when you are configuring the Kubernetes. Right. So if you are going for the self-managed Kubernetes, like in your own environment, then you have to make sure after provisioning of the machines, either physical machine or virtual machines, you have to install and configure each and every component by your own. Right. And once that is done, you need expertise as well who can manage the complete end-to-end infrastructure However, when we go for the managed Kubernetes, then every complete infrastructure along with your cluster components and everything is handled by the cloud service provider. And when you are in your self-managed Kubernetes, then everything has to be managed by you. And you need good Kubernetes experts who can manage your environments as well, right? Along with the development of your applications, which is going to run in the multiple containers in the pods in your Kubernetes. Right. So this is one of the major difference. And third is local R&D development testing environment. So apart from that, if you are on in a local development or testing environment or in your research and development environment, you are installing the set up your own local machines for learning purpose. For that, there are multiple different distributions. For example, Minikube. Okay. So that you can easily install in your local machines, okay, within a few minutes of time, okay, which will simulate the complete end-to-end Kubernetes cluster in your local machine. That means it will install the complete components, whatever is required in your master node and in your worker node in your single PC. Okay, so that your single PC in that will act as a master node as well as the worker node. Okay, so this will simulate the complete end-to-end Kubernetes cluster in your local environment. And after that, you can run each and every command whatever you run in the managed Kubernetes cluster or maybe in the self-managed Kubernetes cluster. Okay, so that means it's very easy for you as well to set up your local environment as well for testing or development or your own local learning purpose as well. So that means you have three different kind of distributions or flavors for each and every depend on the different kind of a requirements, right? So these are the component. Some of the component will run on your Kubernetes master node, and some of the component will going to run on your worker nodes where your containers are running, right? So Kubernetes is considered a distributed system. Why it is called a distributed system? Because it has a multiple components. Some of the component are installed in the master node and some of the component are installed in the worker nodes, right? And it manage and coordinate the deployment, scaling and operation of containerized application across a cluster of machines. So that means you have multiple cluster of machines which is called the worker node, and then you have multiple pods and there are multiple containers are running inside the pods, and your Kubernetes master node is doing the end-to-end management of your all the pods, which include your deployment, scaling, and day-to-day other operations as well with respect to the applications. Right. So now let us talk about the benefit of managed Kubernetes service. That means which is managed by the cloud service providers. So reduce operational complexity. Right. As I said that now you have infrastructure completely on your cloud service providers. So the complete infrastructure is going to manage by the CSP, cloud service provider. Then complexity will be less. Improve reliability and security. So because it is completely on the cloud, which has a multiple security solution in place, and then you have a reliability as well. Okay. That means your service will always be available. Okay, focus on your application. So if you are have suppose you have a you are in a different kind of a domain. For example, you are in an banking solutions. Okay, so your core business is banking, not to manage the IT infrastructure, right? So in that case, there is no sense for you to go and set up a complete end-to-end infrastructure of Kubernetes where you have to hire the Kubernetes expert and then multiple more engineers apart from that to manage the complete infrastructure, right? That is not your core business because you are in a banking solution. So if you're going for a managed Kubernetes solution, then you can focus on your applications and the complete infrastructure of your Kubernetes will be handled by your CSP, not by you. Certain downsides of the managed Kubernetes are less flexibility because, as I said, that completely end-to-end infrastructure managed by the cloud service provider, then you will have a less control over the underlying infrastructure of the Kubernetes. Vendor lock-in, if you are going for a CSP and you have a big setup which is there already built in the Kubernetes cluster of a cloud service provider, right? Then the moving or migration of the Kubernetes from that particular cloud service provider to some different cloud service provider, if you decide in future, okay, that would be a bit complex. So this could be a vendor locking. Now the cost will get increased definitely because again you are uh, going to use the cloud services, right? And then where you complete infrastructure, application, software, support, everything is managed by the CSP. Okay, that means you may have to pay bit higher cost in terms of the end-to-end management and utilization of Kubernetes. So these are the certain benefits and downside of using the managed Kubernetes, right? So these are the different kind of distributions, basic architecture of the components, and how we can utilize the different kind of distributions for the setup of your cloud managed services for your on-premise services, and as for your local setup as well. Thank you.